Welcome to Ask Klein Math. Today we're going to look at 6.7a, a 6th grade standard that's related to generating equivalent numerical expressions using order of operations, including whole numbers, exponents, and prime factorizations. So there's lots to this standard. Let's take a look at what's involved. For simplifying numeric expressions, we have to simplify exponents. So we need to remember that when we are working with exponents, we have a base. So in this case, we have 4 as our base and 3 is our exponent or our power. But that just means that we're going to take this base, and that works as a factor, and then the exponent or that power tells us how many times we're going to multiply the base times itself. So we have 4 to the 3rd power, or 4 cubed. So we're going to take 4 and multiply it 3 times. 4 times 4 times 4, which would give us 64. We also need to know how to work with prime factorization. So we want to break down our number all the way down into its factors that are prime. So here, if we break down 36, 4 times 9, we break it down again, 2 times 2 is 4, and we can't break down 2 anymore because it's just the number times 1, which makes it prime. So 2 times 2, and then 9 broke into 3 times 3. So when we write that as a prime factorization with our powers, we have 2 2s, so that's 2 to the 2nd power, and 2 3s that we're multiplying together, so we would say 3 to the 2nd power as well, or 2 squared. So putting together our order of operations that we learned in 5th grade, we're adding in our exponents. So now we might also run into integers as well. So we're going to follow that order of operations to evaluate this expression. We have 4 times 7 minus 2 minus 6 squared divided by 4. So with our order of operations, we want to start with our grouping symbols. And in this case, we have 7 minus 2, and that gives us 5. Then we need to think about our exponents, and we have 6 squared. When we square 6, we end up with 36. So now we have 4 times 5 minus 36 divided by 4. So now I'm thinking about my multiplicative relationships, multiplying and dividing, because remember, dividing is the inverse of multiplication. So we want to work these left to right. They kind of rank the same. I see multiplication here, and I see division here. I'm going to do my multiplication first because it comes first left to right. So we're going to say 4 times 5. Gives us 20. Then we have minus 36 divided by 4. So our next step would be to divide 36 by 4. And we end up with 20 minus 9. And just like multiplicative relationships, the additive relationship, addition and subtraction being its inverse, we still want to work those left to right. Here we only have subtraction, so we just have to finish this out, and 20 minus 9 is 11. So we're going to put all of this together to apply to a problem that you might see. So looking at this problem, it says, a numeric expression is shown, 5 squared minus 6 times the difference of 4 squared minus 10 minus 3. So we need to think about those order of operations, and I'm going to be thinking about those grouping symbols first. So that's the piece that I'm going to start with. So starting here with our parentheses, our grouping symbols, I see that I have an exponent and I have subtraction. So I need to take care of this exponent first. 4 times 4, 16, minus 10 is what I'm starting with. So now I've still got to work in my parentheses. 16 minus 10 is 6. Now I need to rewrite everything that went with that problem. I see I now have an exponent, I've got some subtraction, this means to multiply, and we have some more subtraction. So based on my order of operations, I'm going to work my exponents next. So 5 squared is going to give me 25, and then rewrite what I have left. So looking here, we have subtraction, we got multiplication, and we've got subtraction again. So I'm going to take these guys here and rewrite my problem. So we could count this as like a -6 times +6, which would be a negative 36, and then minus 3. Remember that negative, if we call that negative, it's the same thing as adding the opposite. So now I'm seeing 25 minus 36 minus 3. So if we work left to right, and we think 25 minus 36, that's the same thing as adding the opposite, which means I'm really going to be subtracting and keeping the sign of the larger absolute value. So 25 from 36 is 11, and 36 has a larger absolute value, so negative 11 minus 3. And when we work this last step, again, it's like adding the opposite. So we have negative 11 plus a negative 3, which would give us negative 14, and we see that over here.